You've heard of supermassive black holes, right? Those cosmic monsters that are at the center of galaxies, with millions, sometimes billions, of times the mass of the sun. They are like the bosses of the universe. And you may have also heard about stellar black holes, which are smaller and form when very large stars collapse. But what about the halfway point? Have you ever wondered if there is a middle black hole? Not too small, not too giant? So it is. There is. And until recently, this was just a theory. The famous intermediate black holes. But now, in 2025, scientists have finally managed to identify more than 300 of them, spread across dwarf galaxies. And bro, this is like finding the missing link in stellar evolution. To give you an idea, these intermediate black holes are between 100 and 100,000 times the mass of the sun. It's as if you have a black hole the size of a city, but weighing like all the cars, buildings, and people on the planet multiplied by thousands. They're too big to be stellar and too small to be supermassive. That's why they stayed hidden for so long. We didn't have the technology or the right focus to find them. Now imagine the following. You are in a quiet neighborhood without much movement, with small houses. And suddenly you discover that in the basement of several of these houses, there is a hidden mini black hole. This is exactly what scientists discovered in dwarf galaxies. Smaller, dimmer galaxies that almost no one paid attention to. And there they were, silent, but hungry. These black holes were found with telescopes that capture X-rays, like the XMM Newton from ESA and the famous Chandra from NASA. They detected radiation coming from these black holes at the exact moment they were pulling in matter, gas, dust, stars, anything that passed by. And this radiation is like a trail, a glowing footprint that betrays their existence. And the craziest, we thought they were rare. But the reality is that they can be everywhere. And if this is true, it completely changes how we understand the formation of the universe, galaxies, and even the origin of supermassive black holes. But don't worry, this is just the first piece of the puzzle. We will understand why these animals were hidden for so long, what they have to do with the emergence of galaxies, and if there are any out there, close to Earth. Okay, now that we know that these intermediate black holes exist, that question arises. Why have scientists only managed to find so many now? Like more than 300 at once? Were they there all the time? And we just didn't see them? The answer is yes. They were there. But seeing a black hole is not like looking at a star shining in the sky. They do not emit their own light, do not blink, or perform a light show. Most of the time, they are completely invisible unless they are swallowing something. And even when they are feeding, so to speak, they are still difficult to identify because the glow they emit, especially in X-rays, is very subtle and can get lost in the confusion of the universe. Now imagine looking for this in dwarf galaxies, which are small, dim, and often forgotten by major astronomical research. It's like looking for fireflies during the day, in the middle of a forest. But everything changed with the use of telescopes like the Chandra and the XMM Newton, which can detect X-ray emissions very precisely. And what did these telescopes find? Small points of light coming out of places that, until then, seemed empty. When the data was crossed, scientists realized that these points came from dwarf galaxies, and more specifically, from the centers of these galaxies. This turned on a light. Wait a minute, could these galaxies hide black holes? And yes, they were hiding it. Many. It's curious to think that for decades we aimed telescopes in the most obvious places, at the centers of large galaxies, in the densest regions of stars. But we ignore the silent corners of the universe. And that was exactly where some of the most important secrets were. This also reveals something about science itself. Sometimes we stop looking at the details for the little one. That doesn't seem impressive at first glance, and ironically, that's where the biggest mysteries lie. These intermediate black holes remained off the radar for so long precisely because they didn't fit into the extremes. They are not big enough to attract attention like supermassive ones, nor small enough to be detected with traditional methods. They were in the middle, quiet, but fundamental. And now that we know where to look, the expectation is that many others will start to appear. The question now is, how many more are there? And is there someone closer to us than we imagine? Now that we know that these black holes exist and that they were there, hidden in small galaxies, the big question is, what does this discovery change in practice? And look, a lot of things change. We have always tried to understand how supermassive black holes, those giant ones that are at the center of galaxies, form. Because like that, it doesn't make much sense for a black hole to simply be born with billions of times the mass of the sun. It's like imagining that a baby is born 2 meters tall. Something is missing from this story. And that's where intermediaries come in as a key player. They are possibly the bridge between small and supermassive black holes. It's as if they were the missing middle of the road in this growth. The idea is that over time, these intermediate mass black holes feed on gas, stars, and even other black holes, and then grow. If this theory is right, it means that these little guys are responsible for creating the monsters that live in the heart of the galaxies. Another important thing, this discovery could change the way we classify and study galaxies. Previously, it was believed that just big galaxies could harbor black holes. Now we know that dwarf galaxies can also. And this greatly expands the field of study. And think about the impact of this on cosmology, because if even the simplest and faintest galaxies have active black holes at the center, then the universe is much more populated with black holes than we imagined. Maybe much more. It also has a practical implication. If we better understand these intermediate black holes, we can better predict where to look for gravitational waves. You know those ripples in space-time that Einstein predicted and that we started to detect in recent years? Many of them may come from the merger of these black holes in the middle. In other words, it's not just a curiosity. It's a discovery that impacts everything, from the formation of the first galaxies to the models that try to explain how the universe behaves today. It's the type of information that can become key in many theories that are still being adjusted. Ultimately, these black holes show that the universe still has a lot of tricks up its sleeve, and that, even though we've been looking at the sky for centuries, we're still beginning to understand how everything really works. Now comes the question that many people ask, half jokingly, half worried. Are there any of these intermediate black holes close to Earth? Well, close in space is relative. But yes, there is a possibility of having some in the cosmic neighborhood. And this is not a conspiracy theory, no. It's science. Remember that these black holes were found in dwarf galaxies? So it is. The Milky Way, which is our galaxy, has several satellite galaxies around, tiny ones, orbiting as if they were moons in the galaxy. Some of them, like the Large Magellanic Cloud, are only 160,000 light-years away from us. Does it seem far? On the scale of the universe, this is almost sideways. These satellite galaxies are also dwarf galaxies. And now that we know that this type of galaxy can hide intermediate black holes, it's natural to think that some of the Milky Way companions also have their own monsters sleeping in the center. And there's more. There are studies that suggest that there may be free-floating black holes without being tied to galaxies. They would be the result of old mergers or ejected by collisions between systems. This means there could be an intermediate black hole wandering alone through space, like an invisible wanderer. And then you ask yourself, if there is one of these around here, is it dangerous? The short answer is no. If there was a black hole of this type close enough to cause a problem, we would have already noticed it. Due to gravitational influence, distortion of light, abnormal movement of stars. But the fact that we don't see any of that is a good sign. Still, just the fact of knowing that there are hundreds, maybe thousands spots of these objects out there, invisible at first glance, already gives an idea of how mysterious our universe is. And in a way, it's almost poetic. We look at the sky, we see that silence, that emptiness, and there could be a black hole there, just waiting for the right moment to be discovered. The universe is this place where the unknown is always there, very close. But we only see it when we start asking the right questions. One of the biggest questions in astronomy has always been, how are supermassive black holes born? Like, They appear in the centers of galaxies with billions of times the mass of the sun, as if they had appeared out of nowhere. But that doesn't make sense. They cannot have been born already giants. Something helped these monsters grow. And now, with the discovery of intermediate black holes, scientists have a new clue. The most accepted theory today says that these intermediaries could be the transition stage, the step before supermassivity. They would have appeared in the early days of the universe, slowly feeding on gas, dust, and dark matter growing over billions of years. In some cases, two intermediate black holes could even merge, and then give rise to a supermassive one. This merger, in fact, would generate gravitational waves so strong that they would cross the entire universe. And this is exactly what observatories like LIGO and Virgo are already detecting. In other words, perhaps we are seeing the end of the story, but are only now beginning to understand what the beginning was like. These black holes that have been hidden for so long could be precisely the ancestors of the giants that dominate the cosmos today. It's like finding a dinosaur fossil and discovering that it was the great-great-grandfather of an animal you never imagined. That's what makes this discovery so important. It's not just about where they are now. It's about what they mean in the history of the universe. And even with all this, there is still a lot we don't know. For example, how many intermediate black holes actually exist? The 300 that were discovered are only those that were active, emitting radiation that we were able to detect. But what about the others, who are in absolute silence? It is possible that there are a million like those out there, floating in the universe, completely invisible. What's more, do they influence the formation of planets, stars, even dark matter? Is there a connection that we haven't even considered yet? In the coming years, with even more powerful telescopes, such as the James Webb and the Euclid, we should find many others. And each new black hole discovered can change what we believe about space, and even our place in it. The most fascinating thing about all this is that, even after decades of exploring the universe, the feeling is that we are still at the beginning, as if we had just opened the door and just looked through the gap. So the next time someone talks about a black hole, remember, not all black holes are the same. There are some there quiet, hidden in forgotten corners of the universe, just waiting for us to notice them. And in the next video, we're going to talk about a black hole that blinks. That's right, it turns on and off like a cosmic lantern, and no one knows why. Did you like this chat? So subscribe, activate the bell, and leave a like, because the universe is just beginning to tell its secrets.